there is presentation from Einstein group. Einstein Bhadra is looking at you. Oh, sorry, Newton. I also became confused. What is this? Here is the picture of Newton. I am saying Einstein. He may be very angry also, right? So Einstein was much younger than Newton, right? So let me welcome on the stage the presentators from Einstein. No, why Einstein coming? Newton's group, Sir Isaac Newton's group, one who has made this slide, Ashwin Shrestha. Ashwin Shrestha is here. So Ashwin Shrestha prepared this slide, and to explain this slide, here is next group member, Deepa Bora. Okay. So, and today's students, they are in out uniform because a full day learning activity. There is only 14 class. Otherwise, people they will be confused. No? Where they are. Please. Everybody, observe in your book.
Namaskar and very warm good morning to you all. As you all know, it's me, Ashwin Shrestha, belonging to Newton group,
Okay.
to present my presentation, and our presentation was like this.
Everybody look at the book, chapter and what they are explaining.
At first, it is introduction of electricity. Electricity is one of the main source of energy today. It is flow of electric charge which can be transported from one place to another place using conducting wire. In fact, electricity is the source of energy, that is the energy in a modified form of other sources of energy like coal, natural gas, oil, nuclear power and other primary sources.
Well,
And another one is electric current. Number one, basic structure of matter. Atoms are made up of subatomic particles like protons, neutrons, and electrons. Protons are positively charged while electrons are negatively charged. Normally, atoms are neutral, but when the balance of charges is disturbed, an electric charge is created. Number two, electric current. For electric charge of a charge to flow, that is electric current to conduct a condition are required. Number one, a closed conducting path between the positive and negative terminals of a power source. Number two, a potential difference voltage between the two terminals. Electric current behaves like water in a park. The difference in pressure in a water park or potential in a circuit determines the rate of flow. Number three, historical context. Ben Franklin proposed the convention for current direction, assuming positive charge flowed from positive to negative. After the discovery of the electron by J. Thomson in 1897, it was understood that electrons negative charge carries flow from negative to positive, but the original convention remains in the use for simplicity. This much. First slide. Electric current. Introduction of electric current. Oh. Introduction to, he already said that introduction about electricity, and electricity is the one of the main source of energy today, and it is flow of electric charge which can be transported from one place to another. And electricity is nowadays we have a widely uses that electricity it used to transfer electricity to one place to another place, and it is used for in our daily life. As we know, it is used to our charge our mobile phone, televisions, and many other things. So in the fact, electricity is the source of energy that the energy in the modified from of other sources of energy like coal, natural gas, oil, and nuclear power, and the other primary sources of energy. And electricity is the modified form of other source of energy like coal, natural gas, oil, nuclear power, and other primary source of energy. And about electronics current. Number one, the basics structure of matters. Atoms are made up of subatomic particles like proton, neutrons, and electrons. And we all know that proton are positively charged, and while the electrons are negatively charged, and the neutron is chargeless, and the normally the atoms are the neutral, but while the balance of changes is distributed in electric currents charge. Number two, electric circuit. For electric circuit to flow of electric, what is this? That is electric current to conditions are required. Number one, a close conducting path between the positive and the negative terminals of a positive power source. And number two is a positive potential difference converted between the two terminals, and the electric current behaves like a water in a water park. The difference in pressure can a water park or the positive potential in a circuit determine the rate of flow.
Reading only, not experience.
Sir, I confused with this capital letter, sir.
Capital letter?
Yeah.
Next time make small letter, okay?
This became automatically.
Okay. So you have to prepare. You have to prepare and be up to date and come. Hey boys. Okay. Thank you, Newton group members. So next time I hope the captain who is going to explain must read very carefully and come. Okay, tomorrow whose duty is there? Tomorrow, second part. Einstein, who is going to read? Who is going to read? And who is going to explain? Who are the members? Okay, who is going to read? Okay, Swarnima will read and you explain. Please, while explaining, you should not go through that line by line. Okay. So see here. So Ashwin has made very lovely presentation. Yeah, presented by Group Newton, Chapter 11, Electricity. Electricity, it comes from the word electron. Comes from the word electron. What is electron? Electron is negatively charged particle present in an atom. So, negatively charged particle present in an atom. So, when we talk about atom, atom contains proton and neutron at the center. Proton is positively charged, neutron is chargeless, and electrons, they are negatively charged. So, these electrons are very light and these electrons can move from one place to another place. When the electrons move from one place to another place, that is called electricity. The fan is working because of electricity. Your mobile gets charged because of electricity. The smart board is also functioning because of electricity. When I switch off that one, then it does not function. But I am not going to do that work. It will hamper our work right now. Okay. Yeah, Newton has gone. Introduction of electricity. It is source of energy because from this we can operate many more things. Not only that, electrical energy can be converted into other forms of energy also. Other forms of energy can be converted into electrical energy. How is electricity produced in Nepal? From water. That's why it is called hydroelectricity. Sometimes electricity is produced from petrol, diesel. That is called thermal electricity. What is that? Name also is different, isn't it? So, if the electricity is produced from wind, that is wind electricity, moving air. If the electricity is produced from solar electricity, but from different sources, other sources. From coal also electricity can be produced. From geothermal energy also electricity can be produced. Geothermal energy. What is geothermal energy? The energy obtained by trapping interior heat of the sun. What I said? The energy obtained by trapping interior heat of the sun is called geothermal energy. From geothermal energy also electricity can be produced. So it is secondary source of energy produced from other forms of energy, and it is given here. It is produced from coal, natural gas, nuclear power, and other primary sources. What do you mean by subatomic particles? Smaller particles, I have already shown you, proton, neutron, electron. So, proton and neutron, they lie at the center, that's why they cannot move from one place to another. But electrons can move, that's why when there is flow of electrons from one place to another, electricity is generated or produced. Here is given electric circuit. So, when we talk about electric circuit, what is electric circuit? One is plus, another is minus. Have you seen battery? There is plus and minus. Have you seen Mac or not? In these wires also there are two wires. One is positive wire, another is negative wire. One is phase wire or live wire, another is neutral wire. If there is only one wire, then will that function correctly? It doesn't. So the closed path through which electrons can move, this is called electric circuit. This is the diagram of electric circuit. This is source. What is this? Source. What is this? Load. What is this? Wire. These wires are closed or open? They are closed. It's not open. Sometimes what will happen? What type of circuit is this? Open circuit. But if we keep their switch, now closed circuit. The fan is working because of open circuit or closed circuit? Closed circuit. Switch is on. But when you make switch off, then that is open circuit, it does not function. So here, charges flow from negative terminal to which side? Positive terminal. There is given potential difference. What is given there? Potential difference or difference in potential. In this side, negative charges are more. In this side, which charges are more? Positive charges. So, these negative charges flow from higher side to lower side. That is called difference in potential. Here are less negative, here are more negative. So, they flow from the region where there are more negative charges to more to less negative charges. That's why electricity flows like this. It is given here, electric. We have to remember Ben Franklin and who is next? J. Thomson, 2%. Earlier, people they believed that charges flow from positive terminal to negative terminal. Who said that? Ben Franklin. But the reality was found by whom? J. Thomson. He said that charges do not flow from positive to negative, they flow from negative to positive. Because electrons are flowing, protons are not flowing. Now, what is electric current? Definition hasn't come here. Is there any definition of electric current? The rate of flow of charges in unit time. The rate of flow of charges in unit time is called electric current, and electric current is denoted by I. How is it denoted? By I. I equals to Q by T. What is the formula? I equals to Q by T. What is I? Current. What is Q? Charges. The rate of flow of charges in unit time is called electric current. I equals to Q by T. I is current, Q is charges, T is time taken. Sorry? Current, electric current. So, SI unit. In which unit current is expressed? Ampere. Ampere. A-M-P-E-R-E. Ampere. So it can be written as A. 1 ampere equals to 1 coulomb by 1 second. Charge is expressed in coulomb. What is the sign of charge? Coulomb. 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 And S, second. How do you define 1 ampere current? The rate of flow of 1 coulomb charge in 1 second is called, what do you call it? 1 ampere current. The rate of flow of 1 coulomb charge in a unit time. Unit time is called 1 second. Eh? Unit time is called, what do you call it? 1 ampere current. The rate of flow of 1 coulomb charge in a unit time is called 1 ampere current. Question can be asked like this also. And next thing, he has not brought numerical problem. I will guide you one numerical problem. Okay. So SI unit of current is ampere. Other SI units are MA and mu A. What is MA? What is MA? Milliampere. What is mu A? Microampere. Lesser current is expressed in milliampere, more less current is expressed in microampere. So the highest unit of current is ampere. MA is milli. MILLIAMPERE, and mu A micro. MICROAMPERE. These are things. Now I will guide you one numerical problem, and then I will just ask you to read and make notes. Is that clear? Can I rub it out? Very easy. Now calculate the amount of current flowing through a conductor. Calculate the amount of current flowing through a conductor when 3 times 10 to the power 6 coulomb charge flows. FLOWS flows in 2 minutes. What is the question? Read the question together. Flows, not flows. Flow in 2 minutes, right? Okay. Solution. Okay. Amount of current. Current I. I equals what? We don't know. Charge. Charge written as Q equals to 3 times 10 to the power 6 coulomb. Coulomb is C. And time taken. Time taken T equals to 2 minutes. We have to convert minutes into second. We have to convert into SI unit. So 2 times 60 second, 120 second. We know that. What do you know? What is the formula? I equals to Q by T. I equals to Q by T. Put the value. What is the value of Q? 3 times 10 to the power 6 by 120. Now we can write here ampere. Use calculator. How much does it come? 3 times 10 to the power 6 by 120. Oh, girls, use calculator. Sorry? 2500. 2500 ampere. 3 zeros. If so, we can write here 2.5 times 10 to the power 4 ampere. You must be able to express that in scientific notation. Is that clear? You are the student of science, that's why you have to do. So the scientific notation has got many more advantages. And everybody must follow Anupam pattern of handwriting. Eh? Which pattern of handwriting? Anupam pattern of handwriting. Understood? Okay. So this type of questions you can solve accordingly. One idea, let me give you. One triangular formula can be made for remembering this formula. What is the formula? I equals to Q by T. Children, very easy. Eh? I equals to Q by T. Q equals to IT. Oh, children. I equals to Q by T. Q equals to, they are in same line, no? IT. T equals to, what is the formula? Q by I. This triangular formula must be remembered. Okay? So that is the end of lecture on 2081, Bhadra 10th, Krishna Janmastami. Right? Okay, children, open your book, everybody. Read once again. Set in your mind, make clear concept, and then what to do? Write in your fair copy. Now, note making time. Is that clear? Come on.